this, we're learning to balance chemical reactions. We're not predicting products. RXN is my shorthand for reaction. So RX and S is just plural reactions. So this isn't bad. You don't have to predict what the products are. You're given an entire reaction. So we could start with a simple one. Hydrogen and oxygen forming water. We learned from mass conservation that the number of hydrogen and oxygen atoms we start with have to equal the number of hydrogen and oxygen atoms we end up with. And that's all this is doing. We use something called stoichiometric coefficients. They just sort of enforce this mass conservation. And it allows us to calculate or predict amounts of reactant needed. And I use capital R for reactant. And amounts of product, I use capital P for product. So our rules for balancing are pretty simple. You can't add compounds or elements to what's written. So you can't say that I've H2O. So you can't say, well, I just need this. You can't do that. You can't change the formulas of the compounds. Okay? Can't change the formulas. And by that, really, I mean the subscripts. You can't do that. Don't do that crap. You can't just say, oh, that's inconvenient, so I'm going to start calling water names. No? Okay. You can't do something like that. You can't just change it. That's going the wrong way anyways. All you can do is change the amount of molecules or moles of molecules or elements. All we can do is change this cofactor. So with a simple one like this, it's pretty straightforward. I have 2 hydrogens and 2 oxygens on my reactant side. So I've got 2 hydrogens and 2 oxygens on my reactant side. On my product side, I have 2 hydrogens, but I only have 1 oxygen. Now here's the thing. When you change the coefficient, when you change the number in front of a molecule, you're changing the amount of all of the atoms in that molecule. So I need to double up at least. So, okay, now I've got 2 oxygens and I've got 4 hydrogens, which is fine. My oxygens are balanced, but that means I need to put a 2 in front of my diatomic hydrogen gas. And this just remains a 1. What this really looks like is this. I've got 2 hydrogens, 1 oxygen, and then I've got, I'm not drawing in my lone pairs for those of you that already know geometry. So that's really what this means. I've just got 2 hydrogen molecules, 1 oxygen molecule. I can form maximum amount 2 molecules of water. So I've got 2 oxygens, 2 oxygens. I've got 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens. That's all that means. Question? Like way up here that you're not allowed to do? The balancing? So I'm just counting the numbers of atoms based on the subscript. right? So 2 hydrogens, 2 oxygens, 2 hydrogens, 1 oxygen. The only way I can make the oxygen catch up is by multiplying the whole thing by a number. So I put a 2 in front, which means I get 2 oxygen atoms, but it also means I have 4 hydrogen atoms. So I balanced my oxygens in that one step, but then I threw my hydrogens out of whack. So now I have to kind of even up the hydrogen count. So I put a 2 in front. Because it's only hydrogen in that molecule, I'm only changing the number of hydrogens. Yeah? Hey, don't be a snob. Guess and check is a totally legit way of balancing equations. What I normally do is I look for odd versus even. And so if one is odd and one is even, the first thing I do is double up. That's my method. Let's do another one. Let's do a combustion reaction. These ones are kind of tougher. Okay, so this one's a little bit tougher. We did the easy one first. This one's going to be a little tougher. So the thing here is balance the elements that are by themselves last, right? So I'm going to do that one last because that coefficient changes only oxygens. For combustion reactions, we usually use the mnemonic device CHO. We usually balance the carbons first and then the hydrogens and then the oxygens. But no matter what kind of reaction you have, balance the ones that are by themselves, like just one element, balance those last. So I like to write the elements underneath my reaction arrow. I only have carbon, oxygen, and hydrogen in this reaction. If you have elements that are not on the other side, like I think there's a typo on one of the problems, if you're missing elements, it's a typo. We're not doing transmutation of the elements. That's next semester when we do alchemy. Just kidding. Okay, so I'm going to keep track. I've got 6 hydrogens on this side. I've got 6 carbons, 12 hydrogens. And I've got 6 plus 2, I've got 8 oxygens. Over here I have 1 carbon, 2 hydrogens, and 1, 2, 3 oxygens. So what should I do first? I'm going to start with carbon just because I wrote it that way. So I'm going to do 6 here. Is that the only thing that changes? What else changes? Right, so now I've got 6 times 2, which is 12 plus 1. Right, so 12 plus 1, so now I have 13 oxygens on that side. Now I'm going to balance the hydrogens. And I might have to go back and change things, or I might have numbers that are big and I can divide by a 2, and that's fine. If your numbers get too big, you can just divide out. That's not a problem. I'm going to multiply this by 6, right? 6 times 2 is 12 and 12. The other thing you need to look out for is I've got oxygen in a couple of different compounds on both sides. A lot of times people forget and they'll just find like one oxygen in one compound and they'll only count that one. Make sure you're counting all of the oxygen or whatever element on that side. Okay, and that changes this too, right? So now that's a 6. So now that's 12 plus 6 is 18. All right, so I've got 6 here. And I don't want to change that because that's going to change the carbons and the hydrogen. So I'm going to take out 6 and see what I need to make up for, the number of oxygens that I need to make that total 18. If I take out the 6 here, I have 12 left. So how about I put a 6 here? So 6 times 2 is 12 plus 6 is 18. I'm going to use that 8. So now I've got 18 and 18, 12 and 12, 6 and 6. If you don't have a number there, it's an understood 1. We usually don't write it out, just like a subscript. This means 1 mole of this hexo sugar reacts with 6 moles of dioxygen gas to form 6 moles of carbon dioxide and 6 moles of water. Okay. We're going to take a little break.